My name is Bob Atkinson. I'm Director of Policy Research here at CITI. I've been given the distinct pleasure of moderating a panel of noted innovators and implementers in technology and technology policy, which is in fact a very accurate description of our panel today. The topic for the session is infrastructure and technology. We have three speakers. Their bios are in your handouts, so I won't spend time going through those. The order today is going to be Greg Harper, Milo Medin, and Robert Pepper. I'm sorry. Yes, they switched. Robert Pepper, then Milo. Thank you, Bob. So without further ado, Greg Harper.
Okay, thank you. This is supposed to be a session on technology. I thought I would do some technology. And actually, there's been a lot of misconception about Ultra HD, and that's one of the things that was on the agenda, is what is Ultra HD and is it something important? So I thought I would give you a brief tutorial. Now, there's a bunch of numbers up here and things like that. I'll try to simplify it and not make it technical. But basically, as we all know, video is going to be increasingly delivered over the internet on IP. And you can see already by this slide the amount of video that's being consumed in terms of consumer internet traffic. It's huge. Now, why is this important? Well, because Ultra HD is coming. And what is Ultra HD? And if you look at this chart here, you'll see the uptake of Ultra HD TV sets. Just so you know, today you can buy a 1080p TV set for under $1,000 for a 55-inch set, a decent one, a not so decent one for $500 or $600, and you can buy an Ultra HD set for about $1,200. So it's not the $10,000 expenditure that I had before. So why in the world do we care? Is it going to take off? That was one of the questions that was in the questions that Ellie put together. So I thought I would try to answer it. So first of all, what is ultra high definition TV? A lot of people have ideas of what it is, but I'm not sure everybody really truly understands it. So I'm going to try to clarify that a little bit. So the first thing is, it is a four-leg stool. There are four parts to this equation. One is higher resolution. That's where the 4K comes from. That's only one part of it. It's also a wider color gamut, higher dynamic range, higher frame rate, and I'll get into that in a little more detail. So resolution. So basically, first of all, there's one confusion. There are two different UHD TV. When you say 4K, it's actually two different numbers. There's 4K in production, which is 4096 by 2160. That's what the film people use. And then there is the more traditional, what the folks in the world of consumer and what you get on the TV set, which is a lower resolution. Basically, it's 2x the HD set. So instead of 1920, it's 1920 times 2, and instead of 1080, it's 1080 times 2. People are now, you hear 1080p, people are now using the term 2160p as a reference for this. If you look at it though, it's algorithmic. So it's geometric. So 4K, 3840 by 2160. That's what the consumer looks at, and that is 4 times the resolution of HD, which in turn is 21 times the resolution of standard TV. So if you look at plain old TV and you look at Ultra HD, it's 21 times the resolution. But what does that mean? I mean, more pixels. And a lot of people argue that if you're a small TV set, you'll never see it. And that's why I say that there's a lot more to ultra high definition than just pixels. Pixels are nice, but I can do those pixels, by the way, on my cell phone today. My cell phones do ultra high definition. So the next part of this leg is wide color gamut. Now, what does that really mean? There's some there's some standards that have been put out. Reg 709, which is an 8-bit standard. There's Reg 2020, which is a 10 and 12-bit standard. That's what UHD TV. Basically, what it means is you get a much larger color palette. It means more vibrant colors that cannot be displayed in HD TV. And that you will see whether you have a big screen or a small screen. So the pixel count does matter, but on a small screen, you will still see the color gamut. So that triangle, if you look at that's visible light there, so the triangle Reg 709, that's HD TV. That tells you what you can see in the HD TV. As you can see, 2020 is Ultra HD TV. You can see it's a much larger gamut of much more pixels. And so you get a much brighter and a much more dynamic color presentation than standard. So it's not just pixels, it's also color gamut. The second area is high dynamic range. Now, if you've got iPhones and other things like that, you may have seen the HDR function on your phone. What high dynamic range basically means is the difference between the whites and the blacks and where you can see things. If you take a look at this picture, it's on a projector, it's even harder to see. But if the picture on the right, that's standard. Now, you notice it's a nice picture, but you can't see any detail in that building. That's because there's not enough the dynamic range is too high. Your eyes are amazing, and they can see the difference, and you would be able to see that with your eyes, but a camera can't see it. So high dynamic range basically allows you to see all the details. So it's the difference between the whites and the black. So what happens is the cameras are shutting down, and they're not able to show it. So high dynamic range is what adds to the equation. So that's another of the four legs of the Ultra HD. The fourth leg is high frame rate. Now this gets into, again, a bunch of math, and you probably can't read that up here. But basically, frame rate has been a very interesting story. Frame rate, basically, when we started off with film, frame rate was variable. I don't know if you realize that, but frame rate depended on how fast the guy cranked the projector. In fact, that's where the term overcranking and undercranking goes. And in fact, the script for the projectionist would actually tell him when to crank faster and crank slower, depending on the scenes in the film. And that would be synchronized with the organist to be playing. So the organist would be playing, the guy'd go, and there was exciting scene, he'd crank faster and faster and faster, and the slower scene, he'd crank slower. So there was, in fact, a performance by the projectionist. So when the films came out, Edison came out with a concept that you really needed about 44 frames per second so you wouldn't see all the motion blur, the wheels, the wagon wheels going backwards, etc. So there's been a lot of debate on high frame rates. We settled on a 24 frame because that was the lowest that you could get by with and still keep the film costs low, because when you were sending film, they were trying to send out film at a lower, less film out there. So 24 frames per second, there's less film, less money to distribute, and that was good enough so that you wouldn't see the flickering, but not really, really, really great. So we've been stuck with 24. Now the film purists, of course, saying, but 24 is beautiful, but there's a lot more than 24. So when we have when we had standards for television, we had something called interlace. Basically, because of the CRT tube, what we did is we ran the picture and we wrote across the tube with the electron gun. We got the bottom, we turned the gun off, and it ran up the back of the top and went back down again. And it's time for the tube to slowly fade away, because remember, it's a tube, it wasn't instantaneous. So that's where we came up with this interlace. So when we say 60 frames per second, it's not really 60, it's actually 60 fields. And it's 30 frames per second. The Europeans use 25. Now, where did 60 and 50 come from? Came from the line frequency of the current, because they didn't have oscillators, didn't have technology that would actually do this. We'd measure the voltage going from the cycles in the current to be able to make this happen. So, make a long story short, we end up with a very low resolution. We only are really looking at 25 or 30 frames, and we're only looking at half the frames at a time. So we're fooling your eyes, and that is not enough. It's just good enough, but it's not really, really high quality. If you look at all broadcasting today, it's still, unfortunately, in the interlace capability. Well, not always. ABC is still doing 720p, but we're still doing interlace for the most part. On the other hand, as Ellie was just pointing out earlier, with the innovation, the people today producing things, they don't shoot an eye. Video conferencing isn't an eye. In fact, we all shoot at a much higher frame rate. We shoot progressive frames, which means they're full frames, and we run at least at 60, if not 120, if not higher. We talk virtual reality, 60 frames won't cut it. Because the whole idea about virtual reality is you're supposed to move your head, and as you move your head, the things have to move as if I'm moving here. When I move my head, things don't start shuddering. If I did that in regular TV and moved my head in virtual reality, you'd do all this, and I'd lose the illusion. I'd lose the impact. So high frame rate is very important, and that's also part of ultra high definition TV. Now, Ellie pointed out something before in his opening comments. He ran the math on how do you get this stuff out there, because you start adding high dynamic range, high bit rate, more pixels, and higher frames, and you add all that up, and next thing you know, you're going to have a lot of megabits. And all of a sudden, you start saying, well, how am I going to get that all out there? Well, the good news is there's something called the HEVC, the High Efficiency Video Codec, which is a new algorithm and a new technology to, in fact, improve the transmission of the compression and transmission. So MPEG-2, which is the first column on the left, that's what we all watch. That's what we use for TV today. That's what your cable box, that's just satellite run, that's all MPEG-2. H.264, which is the next one down, that is what we typically use on the internet today. That's when we do streaming video. It's all some variation of H.264, or otherwise known as AVC. But now HEVC has come along, and as you can see, that's halved it again. So the net result is, if you look at these two pictures, again, because of the projector, you probably can't see the difference, but there is no difference. They look the same. The difference is in the numbers. The one on the left is the high resolution. The one on the right is the low, is the high compression. The one on the right is the low number. Bottom line is, it's half the bit rate for the same picture and same quality. Or, in other words, I can have the same bit rate we have today and double the quality, double the output. So I worked on a project a number of years ago where we did 3 Ultra HD 4096 by 2160 images compressed together. So each coming out of each camera was 12 gigabits, so it was 36 gigabits of data plus audio. And we took all of that, and using these new techniques, we got that down to a 600 megabit stream in bidirectional, or about 300 megabit stream with very, very little latency. We used it for video conferencing on a 30-foot wall. Bottom line is, it is as close to reality as you're going to get with the technology of a few years ago. Today, I can probably even increase that. As we go to 8K, I'll be able to do even more. So as you're seeing, one of the keys, of course, is the codec. Now you say, okay, these codecs are really great. How do we get it? Well, HEVC is brand new. It was developed in 2013. It was just ratified this January, and because of the wonderful world of technology, guess what? The products are out there. There are chips, and to show that they're there, and there's not just pictures, I brought some. This is the new Amazon Fire. Looks just like the old Fire, except this one is HEVC, H.265. It will do Ultra HD. This is a 4K media streamer. It says 4K Ray on it. Look at these things. All of these things, by the way, 100, 150 bucks. Here is the Open Hour, another unit coming out. The Roku 4 is coming out in a couple of weeks. This is the NVIDIA, which is also adds all of this plus gaming and a terabyte drive on it. And this is, again, HEVC. And TiVo, don't knock those guys out. I didn't bring the DirecTV box. I didn't bring the Comcast box. I didn't bring the Dish box because they're hooked up. But this is the TiVo box. And this is also Ultra HD 4K. All of this is possible because the chips exist. These same chips, by the way, are going into your cell phones. These same chips are going into your computers. These same chips are going onto your graphics cards. So HEVC is really, really going to happen. There's the picture of all this stuff here. And what's coming down the pike very shortly is Ultra Blu-ray. So we're going to see, those are the 2 discs. Both of those will be out this Christmas. So you're now going to have content distribution. But it's really going to end up becoming, I mean, I think Blu-ray is going to be sort of a last gasp of the industry to try and distribute physical media. It's really going to end up becoming live stream. Now, you take all of this technology, you take the ability to compress it, you take all of the attributes of ultra high definition TV, you throw that into virtual reality glasses, because you can put that now in your phone goes into your Oculus headset, and now you've got all this super high resolution. And trust me, I mean, like someone mentioned the Paul McCartney concert. You know, I've actually watched that crazy concert multiple times. It's a lot of fun. You're on stage with Paul McCartney, and you watch the show. And there's a Cirque du Soleil one where I'm sitting in the Cirque du Soleil, and the performers are sitting next to me, behind me. There have been soccer games. There have been all kinds of things now, and you're going to be seeing a lot of it. And now there are virtual reality cameras. I didn't think we were going to talk about virtual reality, so I didn't bring it, but I just got there's a new camera just came out, exclusive at Best Buy right now, called 360 Fly. It's a round ball, a little smaller than a tennis ball, sort of cross between a ping pong ball and a tennis ball, sort of in the middle there, if you can imagine that. And it shoots 360 around, and then you can play this on your phone or your headset, and you can move your phone, Skype around it, and all the rest. It shoots a 360 image around it. This is all happening. GoPro, of course, is doing their version of it. Google's doing theirs. So you're going to see a lot of these things happening. And as these things happen, it's going to end up becoming something that we should all be looking at. So I just want to thank you for just indulging me to understand a little bit. Hopefully you understand a little bit more about UHD TV and where it's going and the compression. But it's all happening. It's not science fiction. And yes, I believe it absolutely will happen. And I believe it will happen very, very soon. So the question that you're asking is, will it become a success? The answer, I believe, is absolutely yes.
Our next speaker is Bob Pepper from Cisco.
Screen. Great. Thanks, Rob. I love following Greg because, in fact, he makes the point that what I'm going to talk about is real, and also this morning's sessions. Ellie, I thought it was really, really good. And Ellie, the way Ellie teed it up. So I'm going to talk about what we're seeing is sort of how is this going to be transmitted, right? All the video over what kind of network and what does that mean? And every year, I mean, I talk about our forecasts. Is really a tale of two networks on one network. We have this forecast that we do every year. It's the Visual Networking Index forecast. It's a 5-year rolling forecast of everything related to the internet, things connected, people connected, data, et cetera. But since it's a 5-year rolling forecast and we've been doing it for 10 years, we actually can go back and report out how we did. When first time I actually reported out, people said, "Oh, nobody ever does that. Nobody ever actually tells us how you do." They have a forecast and then they disappear. Once again, we're within about 10%, which is not bad in this space on a 5-year forecast. And each year it's typically within 5%, usually on the conservative side. So overall, what we're forecasting, and I'm focusing here U.S., we have data globally, we have data by different regions, different countries, but I'm going to focus on the U.S. That internet protocol traffic is over the next 5 years growing at about a 20% CAGR. That's sort of top line. That's actually not all that interesting. But when you take a look at the various components, there are a couple of things that jump out. There are 4 variables that drive data growth on IP networks. Number 1, adding more people. Well, in the US, we're not adding more people. I mean, we are incrementally, which is a mature market. 87% of every man, woman, and child is sort of connected in one way or another. That's sort of organic growth, right? If I'm in India, you're adding people who've never been connected, right? We're forecasting over the next 5 years, 1 billion new people will be connected globally, right? Which is a milestone because that means about half of the global population will be connected by 2019, but there's still another half to be connected. There'll be more devices. We're in the U.S., it's about the devices, right? We're going to double the number of devices with IP addresses connected over the next 5 years. 85% of those are going to be machine to machine. I'm going to talk about that. So the incremental number so we're talking about 2 billion more devices in the U.S. Connected over the next 5 years, and that's going to be, and I'll talk about machine to machine. Networks are getting faster. The traffic, 85% of the total traffic is going to be video, and that's the first tail of the 2 tails of the networks. And what we're seeing is that, again, 85% of the traffic on the fixed networks are going to be video. Even on mobile, 75% of the traffic is going to be video, right? And this is exactly what Greg's talking about, because it's in your mobile device. And I can go back and do deeper dives in this, but I want to sort of get sort of the top lines, and then we can have a conversation. It's not that we have more than 24 hours a day. It's not necessarily that we're watching more hours, although we are. But what we're seeing is the shift, and Ellie, you did a really nice job at the beginning. We're seeing the shift from traditional broadcast, we're seeing, and traditional cable, we're seeing more of this online. But when we're online, and by the way, there's no way to deliver the 4K or the 8K other than online, right? That's not, everything that Greg talked about is being delivered over IP networks, right? But what we're seeing is this dramatic migration from standard definition television, right, to HD to 4K, right? And here in the US, which is really sort of leading the 4K adoption revolution. By the way, 3 years ago, actually it was 4 years ago now, the industry was talking about 3D, which when in our forecast we said no. We actually in a 5-year forecast said that will not be adopted. And methodologically, I can talk about how we do that, and talking to the chip makers, the consumer electronics people, the content production people, et cetera. But 2 years ago, we said this 4K thing is going to take off, and actually it has. And so what we're forecasting is, when you look at this, your HD and 4K is going to account for 83% of the video traffic on IP networks by 2019. Right? So that's really taking off. So, but I totally agree with what Greg said. It is absolutely real. And translating Greg's graphic, what does that mean? What we're seeing is that the HD, the standard definition television online today, we're going to have to see what compression looks like. But right now, that's 2 megabits per second for standard def, 7 megabits per second for HD, and then when we get to the Ultra HD, it's 18 megabits per second. And we'll have to see what the HVC, the H.265 does. But again, this is what's driving the demand on the network. And then we had something, so our latest forecast was released on May 25th. And we had a wild card in there. And the wild card actually became not a wild card on May 27th. Because the wild card, which I'll actually, let me get to the wild card, and I'll come back to the other stuff. The wild card was 3/6 of immersive video, right? People were talking about it, but nobody was actually doing it. And then on May 27 at the Google I/O conference in San Francisco was the announcement of the YouTube and the GoPro with the 360 video.
And with cardboard.
Right? With cardboard. And and again, we've already seen some of that and what that means. But if you're looking at ultra high definition video in 360-degree surround, and think about the 2020 Olympics in Japan, by then that's going to be standard. But the only way you're going to get that is over IP networks. That's not what is going to be the broadcast or even on cable. That was a wild card. That is no longer a wild card. So you can just think about what that means. Now, going back to other things that we're seeing, and we're seeing a shift that the internet absolutely already has become the next prime time medium for the way people consume video. And what we see is that globally already, this is actually not peak hour, it's peak time, and it may be more than an hour at night, but it's usually between 9 p.m. and 1 a.m. There is a time that's the peak time, and peak over average was to about 2.5, was globally about 2.5. In the U.S., North America, it's already 3.3 times average, and it's going to grow to 3.7 times average. Right? So average in terms of the network and network configurations, average doesn't work because you have to be able to accommodate a peak over average of over 3.5x. And you can see in the US what's happening with a busy hour versus average hour in terms of what the growth. The gap between average hour and busy time is growing and growing significantly. But this is not just on fixed. And you can see that the fastest growing, the digital TV household, this is subscribers. Is growing at about 5% CAGR globally. Online video at 7%. Mobile video is growing at a 21% compounded annual growth rate. So there is this shift to the mobile and the wireless consumption model for video, right? And increasingly high definition and ultra high definition video. And the other thing is, as people are, sort of cut the cord from traditional cable subscriptions, the cord-cutting household generates more than 2x the traffic. So the cord-cutting household generates 92 gigabytes per month, compared to 43 gigabytes per month for the average household. That includes the cable subscriber. So as people shift away from the cable subscription into IP video consumption, you see what happens. And that is, again, a trend. And this afternoon, I assume Craig Moffett will talk about that because Ellie, on one of the fellows calls, the question that, Craig's talking about the trends, and he talked about, there was the question about, well, gee, people in the traditional industries are saying, oh, this cord cutting thing, the millennials, once they get married and have families, they'll go back to traditional cable TV, right? And Craig said, don't believe that for a moment. That's what they're telling Wall Street. They don't even believe it, right? And guess what? It's not happening. People are not going back. And there was the comment earlier about upstream, downstream, and that it's not really as much a producer generated. Well, there's a lot of producer generated, and in fact, what we're seeing, and this is not forecast. This is actual from 2014. That about 23% of bidirectional, of the traffic is video. It's upstream video. It's people creating their own videos, including things like GoPro, and that's only going to increase. And again, think about the implications for the networks as they carry that. Now, one of the things that is helping manage all of this traffic is the content delivery networks, putting them on these kind of specialized networks that will take the traffic close to the end user and then cache it, right? I mean, Google's doing this, the traditional one, it's Akamai. There's a lot of these CDNs. So globally, we're forecasting that 62%, by 2019, 62% of all of the internet traffic is going to be over CDNs. But, look at the US. The US is already 65% last year, and it's going to be 91%. So CDNs are going to totally dominate. I mean, so how do we get the traffic, to a local POP in order to be able then to the IP traffic to push it out? Without that, this stuff, it's not going to really work. You're not going to keep going back out and pulling stuff down. It's all, a lot of it is the local caching. So the first tail, of the network, if it's a tale of two networks, is video, and video, streaming video, download video, upstream video, two-way video, Skype video, and that's really leads to a lot of complexity because just managing for all those different types of video, is complex enough. But when we look at the devices, what we're forecasting is that, globally, 43% of all of the devices connected in 5 years are going to be machine to machine. And I'll talk in a moment about what we mean by machine to machine. In the US, that is going to be 58% of all of the devices are going to be machine to machine. And as I mentioned, of the 2 billion or 1.9 billion things that are with IP addresses that are going to be connected over the next 5 years, 85% of those are going to be machine to machine. Now, we also, for the first time, by the way, it's only going to be 3% of the traffic. All right, so people are saying, well, we're going to double the, we're having all of these new devices. We're going to need to have, accommodate, the traffic is going to be just, linearly extrapolated from what we have today with all these new devices. The answer is not so much, right? So 58% of the things are going to be machine to machine, but that's only going to generate 3% of the traffic. Why? Because most of those things are not going to be continuous or broadband. I mean, when you walked in downstairs and there's a surveillance camera, right, all over campus, all right, that's broadband, that's continuous, that's video, that has a power source. It's going to be probably Ethernet, right? But most of these things are going to be, my Fitbit or the module in the connected car. We're forecasting the average connected car by 2019. There's going to be 250 million of them on the road. The average connected car will have 4 modules. Each module will have multiple sensors. Most of those are going to, wake up and chirp little bits of data and go back to sleep, or chirp little bits of data when, my oil pressure goes down or my tire pressure, right? And by the way, most of those are not going to be sensitive to latency. On the other hand, when the airbag goes off because I'm in a crash, latency becomes really important. And in the Google driverless car, or even the assisted cars, right? So if you have a convoy of big trucks, they're driving at 75 miles an hour on the highway, a meter apart. They all have to communicate with each other. You need really low latency, right? Because if the first one breaks, you don't want to have a pileup, right? So we actually, for the first time, have visibility into what we mean by machine to machine and what types of devices. We've identified 12 different verticals, right? About half of them are going to be in the connected home. And again, we have very concrete examples of what that means. The fastest growing category is connected health, along with connected transportation. But when you begin to look at all of these, the requirements for these different types of devices are going to be very, very heterogeneous. Some of these devices, as I mentioned, are going to be sensitive to latency. Others are not. Some are going to have to communicate over inches, some over miles. Some are going to be continuous. Some are going to be bursty. Some are going to be broadband. Some are going to be narrowband, right? And so the requirements of the devices are going to be extraordinarily diverse and heterogeneous, and therefore things like the spectrum is going to be very, very diverse and heterogeneous for those requirements. It's an eye chart. It'll be made available to you. These are the examples of the things for each one of the categories. When we look at the machine-to-machine share of devices globally, right? In Korea, we're forecasting 72%. Japan, 68. Italy, New Zealand, about 61. Spain, U.S. And I did a blog, it was last week before last, on Huffington Post, where I called out what I fear is an emerging new digital divide in machine-to-machine, right? It'll be the third digital divide. The first is phones. That's essentially been closing with voice-only phones. The internet, the second digital divide, we have a roadmap on how that, in fact, is closing, right? It's getting better. It's still there, but we can see how that's going to close. This, though, in my mind, is actually really important because there is a huge, huge benefit in the developing world, the emerging economies, for the Internet of Things, for these machine-to-machine devices to help solve problems like food security, water security, disease detection, et cetera. But in 5 years, the global average is 43%. In India, it's 13%. Middle East, Sub-Saharan Africa, it's only 17%. LATAM, 31%. And in LATAM, there's some countries with pretty high, and others are going to be very low. This is very worrying to me. And while I'm very confident in the numbers in the forecast, on this one, I hope I'm wrong. I fear I'm not. And that's for a whole nother conversation. So what we have is the tale of two networks. One network, it's actually all one network, but on the one side, the capacity is being driven by video, video, video. On the other side, it's these, incremental, 10 billion machine-to-machine connections with IP addresses by 2019, and that leads to huge complexity. Takeaways. All right, traffic is being driven by video, connections being driven by devices. Video is becoming higher and higher resolution, right? Exactly what Greg said. Upload video as well as download and streaming video, and we need to manage all of that for complexity as well as capacity and congestion. Thanks.
Our last speaker, Milo Medin, VP of Access Services at Google.
There we go. Just have the placeholder slide.
All right, great. Ellie, thanks for inviting me to come. I'll talk a little bit about some of our experiences on the infrastructure side, maybe give you some views into the sort of dirty underbelly of video transport that could be interesting. I came to Google about 5 years ago to start Google Fiber, and it's been a great experience. One of the things that I had as a going in assumption that was different than the team I inherited was that we needed to do linear TV. That still is a requirement for competitive broadband entry today. If you don't have linear TV, you end up losing about 50% of your take rate. That's just the physics of the business in the United States. And so when we started to design the video infrastructure, it was greenfield, completely from scratch. We had nothing in place. We wanted to have the highest quality television experience to go along with the highest quality and fastest internet experience. That is not just about getting a gigabit to the home. It's about getting a gigabit through the home. Because if people's TVs are not located just in the room that the fiber is terminated in. So we built, to do this, we actually built our own hardware in terms of set-top devices and infrastructure. We use Mocha 2.0 in the home, which gives us a few hundred megabits of transport throughout the home. It's been very reliable. We wanted to have the highest quality video feeds. Now, this turns out to be harder than you think, because as it turns out, many of the feeds available that feed large cable operator systems degrade the videos substantially from the quality levels that the programmers put out. Hits, at the time we were looking at it, they cram, because the cable industry uses MPEG-2, they cram the 3 HD channels into space that 2 would normally fit from a bandwidth perspective. And that leads to things like macro blocking and quality degradation in the distribution network. It's interesting if you look at Fios, the same program, because you can get cable card devices for both Fios and for cable, the same program recorded exactly the same time increments, had 40% more bits in the Fios version on storage than the cable version. And those bits all represent resolution. So what we did is we built our own national head-end complex at one of our data centers in Council Bluffs, Iowa. That facility downlinks from both satellite and fiber feeds, and we encode HD in about 12 to 14 megabit H.264. So it's actually an incredibly high-quality feed. And it's distributed throughout the long-haul network on fiber. And so it yields a really great experience. So you look at the ticker symbol during an ESPN basketball game, and you don't see any mosquito noise around the ticker. We really care a lot about quality. And in fact, some of our users have asked us, is this 4K? Because it looks so much better than the same channel they got off cable, which was really fascinating. We also wanted to integrate over-the-top sources. Netflix, Hulu, YouTube, more are coming. So they're fully integrated into the guide and the experience. So you could be looking in the more or less what looks like a traditional guide. An episode of Family Guy might be, a rerun of that might be coming up, say, in 2 hours. If you click on that, it'll say, do you want to record or play now? How can you play now? Well, if it's available on VOD or if it's available on Netflix, if you're a Netflix subscriber, it will then initiate a Netflix playback of that specific show, cross-indexing and searching across all your content, not just linear and VOD. That experience turns out to be really, really compelling to users. And one of the interesting things that was that happened just recently, there was an AMDOC study that surveyed, I think, 5,000 households who are potential cord cutters in the cord cutter demographic. They found that 50% of those, more than 50% of those households would keep their multi-channel video service if it was integrated search and navigation with over-the-top. Because right now, today, you have your set-top box from the cable operator or satellite operator, and you have to switch inputs, switch UIs, switch remote controls to go to your Chromecast or your 4K box or your over-the-top box or the TV's interface itself. There's no integrated viewing experience. So we saw what happened last quarter's media numbers in terms of the decline in MVPD subscriptions. Part of that decline is because today the cable and general video distributor set-top experience is one that's completely vertically integrated by the operator. Users do not have choice about set-top boxes and capabilities for linear TV. They do for over-the-top, but not for linear. And so today, the video set-top box is one of the last vestiges where consumers don't have choice. And the FCC may be doing a proceeding on this. I hope they will be active in this, because the future of multi-channel video, I think, is really at stake. Because if we don't end up with these converged experiences, you're going to end up with cord cutting accelerating, and that's going to be a real challenge, I think, for the media companies. Bob talked about CDNs and local caching. Part of the trick of delivering video and doing it over-the-top video, doing it really high quality, is interconnection of the CDNs. So when we started, we put CDNs from YouTube, from Netflix, and from Akamai in the regional POPs in every one of our fiber cities. So when you initiate a stream from Netflix, it's coming from a server that's 1 millisecond away from you. And what that does in terms of reducing buffering, speeding up time to playback for over-the-top sources is really phenomenal. So you can actually start up a 1080p YouTube video, start a second one, a third one, a fourth one, a fifth one, boom, 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 boom. And there's no latency, there's no impact in that. So it's not just about whether or not you have integrated devices in the home, but is the service provider interconnecting locally? There's been a lot of fuss about the FCC's rules about interconnection, but part of the driver is if an operator, if your internet provider is pushing the CDNs onto the other side of their backbone, on the other side of peering and interconnection, and not connecting it locally, you're going to have a very different experience in that how that over-the-top video is consumed, how it feels, how the quality of it compared to having it be local. And some would assert that that's by intent. We want to make all video be the highest, fastest, the highest quality and the quickest response. And we need to do that by doing local interconnection. And I think that's going to be a continuing source of friction in many, many cases. One of the other dynamics with high quality video is scaling. So you didn't really get into, Greg didn't really get into this, but the going from one resolution to another can be done in a really bad way or can be done in a really good way. So there are a number of networks today which are still not HD. They're still standard definition. We wanted to actually make all of them HD by upconverting them centrally at our national head end. And because the quality that we can do with that scaling, because if you've got a 1080p TV set, it's going to get scaled up to 1080p, even if it's a standard def signal, because the flat panels cannot display things in lower resolution. They have to do it in higher resolution. And it's better to do it one place with a really, really, really good scaler than it is to distribute it among TVs which may or may not have good scaling. As it turns out, the content partners actually had issues with this because of MFNs and other things in the 200 pages of the agreement that the TV guys, that the gentleman from Turner mentioned. So I think there's a lot of things that stand in the way of really improving quality of video that's delivered to users. Another thing we wanted to do is, because we're not bandwidth constrained, right? Let us take the feed in 1080p instead of 1080i. And when we talk to programmers, even those who are known for really high quality output, many of them told us that their production pipelines inside the content operator are not capable of outputting 1080p. So they don't have, and so until those pipelines get converted all the way from production to encode to add insert to editing to output, all the way, right, to even 1080p, much less 4K, even if the distribution network is not the constraint, you're going to have challenges, right? And so that's one of the things that's interesting. Part of the reason the over-the-top folks, Netflix, YouTube, Amazon, and others can do 4K is they are a green field. They don't actually have any of the old-style production pipelines. And so they can produce video on the cloud, using the cloud to compute, as opposed to the traditional embedded systems, right? And so they can move to 4K through the production pipeline much faster than traditional video distributors. And that, I think, is a real interesting challenge, because even when the distribution networks are capable of having 4K, and set-top boxes, and many of the DirecTV boxes today, for example, have 4K capability, if the pipeline is not able to process that, it's not going to be available. And so that's just another reason why we look at 4K for a while. It's going to be driven by Netflix, YouTube, and the over-the-top folks, much more so than traditional programmers. There is this other problem that the North American standard for over-the-top on broadcast is MPEG-2 based. So the problem is, that means your over-the-air signals from the broadcasters, there's no path to 4K right now. And what does that mean, right? Are we going to go through another conversion where over-the-air goes to a new codec and broadcast distribution? Or is over-the-air always going to be MPEG-2, lower bit rate, lower quality? And I think that says a lot about the future of broadcast, because either you're going to go through another complete change-out on the over-the-air systems, or multi-channel video is really, the 4K is only going to be delivered over the internet and through other non-broadcast facilities. I will also say a couple other things. I do believe that 4K is going to be aggressive. We're going to see a lot of 4K out there. The question is going to be whether or not it's going to actually look any better. Because our operator is going to continue to do this kind of down-resing and quality constraint to fit in the distribution pipelines, or are we going to actually end up with some mandates that says you can't deliver 4K unless you have some minimum set of standards? I don't know. It'll be interesting to see. It's going to be a challenge. The biggest challenge, however, Greg didn't mention this, but HEVC, the licensing code that's associated with that. Earlier this year, the consortium which sets the standards and licensing decided that they were going to extract a 0.5% of gross revenue license fee. Gross revenue of the operators. Instead of just having a percentage of the box or a fixed fee per device, They wanted the revenue stream. They wanted to get into the revenue stream of the video distributors and the content producers. 0.5% of gross, not net, gross revenue. And this has caused a whole pile of breaking activity going on right now in the 4K industry. Google, working with Cisco and others, as you know, we have an alternate to the HEVC codec family, VP9, and working on VP10, which doesn't have the same IPR licensing problems that HEVC has. And so there's this whole activity going on right now to create an alternative infrastructure to HEVC because of this, what I would call extortionate licensing approach that the HEVC people has done. In the meantime, while all this gets sorted out, it creates a disincentive to invest in all the production and distribution pipelines when it's not clear what codec is going to be actually out there. Because if you allow one set of IPR licenses to get this into your gross revenue stream, it will not be the end, right? You'll have even more coming. So I cannot see anybody in the content or distribution industries embracing this. This is dead on arrival. And it'll take a while to see how this works out. So I think with that, I just wanted to give you a brief a description of some of the challenges that we find in the infrastructure, getting 4K around and other media formats that are a bit heavy, even on fiber networks, where we don't have any problems. Literally, there's no issues in terms of distributing this into the home. You've got to have devices, which today there's no consumer marketplace for that can deal with linear TV. You've got to deal with the distribution inside the home, getting enough bandwidth to do that, codec challenges, and of course, whether or not these 4K feeds actually will be really high quality in the end when they're delivered because of the traditional machinations of the distributors in this space. Thank you.
Thank you, Kate. Come on up. First of all, I appreciate the panelists sticking well within the time limits because now that gives us plenty of time to have some interactive conversation. But first, Greg, you wanted to debate Milo. So, debate.
You're saying 0.5% of gross revenue is not bad? We should be happy about that?
I don't think that's going to stand. I can't see that standing. I mean, the chips are happening, and remember, Netflix is out there doing HEVC, so they're already doing that. And so yes, I think that's just the machinations of. I've been in the standards bodies, and I've seen this happen. So yes, I agree that there are other codecs out there, but the issue I was debating was the question of the quality. You're absolutely right. The traditional broadcasters have no capability of. I mean, they're still on HDSDI, which can barely do 1080i, far less 1080p, and but that's about to change too when we move to an IP delivery for cameras. So we're going to see cameras coming out IP directly, and we're going to be just doing it's going to be more like a Bonjour type protocol where cameras are going to be on there. We'll simply subscribe to it and hook it up. But the quality issue. That, as I said in my talk, is a lot more than just the resolution. It's also the color gamut, high dynamic range, et cetera. That is already existing in the production cameras. Sure. So there's no reason that can't go through. So if I were a broadcaster today, I'd be pretty. I mean, actually, I'm giving a talk later this afternoon. I have 26 executives from the European Broadcasting Union coming to my house, and I brought 3 props. I brought my Oricon 16 millimeter film camera along with a Nagra recorder. So saying this is what it was like when I started. Then I brought a brand new Sony XD-Cam camera that my guys don't even want to touch because they think it's just as old as that Oricon. And what they're shooting with are things like a Sony DSLR camera, the A7S, which doesn't need light, which has huge dynamic range, which has a 400,000 ISO rating, and all the same capabilities. And by the way, shoots 4K. And I can put that in my pocket.
You don't disagree with me that the over-the-air distribution is challenged for this, right?
I think they're toast. I mean,
So actually, you agree, and you have probably one of the most backward-looking group of people coming to your house this afternoon.
There's no question. Come on, Bob.
no, you're absolutely right.
No, and a good example of that is, getting a little, sort of policy geeky at the 2007 World Radio Conference, in which the world decided that 700 megahertz was going to be used for IMT, or essentially mobile broadband. The one region of the world that took a footnote that said, "Oh, we don't think this is going to work," was Region 1, which was because the European broadcasters and the EBU said, "Can't be done." Even though we'd already done the transition in the U.S., we'd from analog to digital. We got spectrum back. The European broadcasters said, "Oh, it can't be done."
Yeah, I'm going to be run out of my house.
No, and effectively, as a result, held the southern half of Region 1, Africa, hostage for at least 5 years because they didn't migrate. They had empty, by the way, there were no broadcasters in sub-Saharan Africa at 700 megahertz. They could have gone directly to a digital, what they call digital dividend, began to leapfrog 3G, which they didn't have, go right to 700 megahertz of 4G with LTE. But it was because of the European, and then they tried the same trick again at the World Radio Conference in 2012. But it was the Gulf states, along with the African states, that said to the EBU and Europe, "No, stop it." Because, by the way, regions 2 and 3, the rest of the world, the Americas and Asia, already had gone forward. So, good luck, and they are toast.
Okay. We'll take, if you have questions, please use the microphone. So kind of stand up, and then we'll see we'll know how many questioners we have.
Bob's going to make you line up.
Line up, and that way we'll keep it rolling. So first question, and please identify yourself.
Cass Calba, Calba International. I've never done this before, but I'm going to challenge the authenticity of one of the panelists. I've been to about 300 of these events in the last 10 years, and Bob Pepper has been to almost every one. So either there's an incredible coincidence or there is more than one Bob Pepper, and I'm not sure if which one we have here, if it's one of the backup virtual ones or the real Bob Pepper. But
It's holographic.
It's holographic. It's 4K or whatever. I do have a question for Bob, and I hope I'm not trying to drill down too deeply, but you talked about the relatively small number of cases where you have continuous broadband requirements in the M2M universe. And what I'm trying to understand, is there some kind of general factor that drives that? Hypothesis 1 is it's where there's very cheap connectivity, a lot of it and cheap. Hypothesis 2 at the other end of the spectrum is that it's where there's very poor data analytics and you're in a very traditional environment and you still got human beings kind of needing to analyze some monitor or something. And so you need kind of continuous stuff rather than something that only bounces every 10 seconds or 5 hours or whatever, and then you get an alarm when the intelligent machine tells you there's something important happening. Or conceivably there are other explanations like regulation or local interconnection or something. Have you looked at that little segment? Because it is
Look
important.
at the segment that is continuous, or
where it is continuous requirements and relatively broadband, so that it does, where it appears, it's going to affect things a little more than the 3% that you said in the aggregate. All this M2M is going to.
So you go back to some of the definitions of the machine-to-machine, where it is continuous. It tends to be the video. There's some other things that are, but the video is the higher bandwidth. And there on the machine-to-machine, actually, Ellen and I were talking about this last night. There's a very high degree of analytics. In fact, Milo was showing me some very cool stuff with AI, looking at photographs and without tagging and so on. It's looking for anomalous behaviors. So the closed circuit video for surveillance or for management, traffic management, and so on. It's really use case driven. It's not regulation. It's not the fact that you have to have people watching it or anything else. It just
And it's not the price of capacity, you know,
No.
that
It
people
really
pay
at
for
this
it.
point it's use case, and most of the use cases it turns out that we don't need, you know, a lot of data. We can have different data points, and then we have the analytics built layered on top of it to get the value, and you can begin to make those, you know, connecting those dots, and you can have the sort of predictive insights and predictive analytics. It doesn't have to be continuous.
Regionally, is this mainly, you know, is
We see the same. We see
US
the
or
U.S. is
everywhere?
3%. You know, Europe it's, you know, maybe 4%. I mean, it's the amount of even in Korea, 72% of the devices are going to be M2M. It's like the total traffic. You know, it's going to be, you know, 5 or 6% of the traffic. So it tends so far. That could change. So far, it appears to be a global, you know, trend phenomenon that we're seeing everywhere.
Next question, please. Identify yourself.
Tom House, GE Asset Management. Running a tight ship, Bob. I'm trying to
Herding
imagine
cats.
graph, and Cisco's got lots of great graphs. But on my graph, one scale, one side would be years, and the other would be some measure of population density or percentage of population, or ideally percentage of NFL viewers. But we've been moving down this graph with fiber. I'm accepting that over-the-air isn't going to be delivering the signal that we want, they want in 5 years or 10 years. So fiber is what the panel primarily represents. I don't know, if you want to throw in DOCSIS, that'd be fine too. But when do we start hitting those important points where 3/4 of all potential NFL viewers can get that 4K signal over a wire, I presume? If Terry was still here, maybe you could talk about Verizon. But when do we start hitting where that line flattens out at 90% or 93% or whatever it is? How many years ahead of that? And how much CapEx has to go into that?
Well, and
I'm thinking U.S. It's a little bit easier, and I think Bob's data seems to suggest the U.S. is a 5-year look ahead for much of the world.
Yeah. Let me take a shot at that. Actually, the economics of fiber deployment are very interesting. There are things that you might not expect. Certainly, cost per home passed in really low density areas, rural, is extremely high. And I think for obvious reasons, right? You have low density, so a number of miles of network you have to construct is much higher for the amount of revenue that you could get off that base. But you would think, when the implication of your question is that the really dense cities are much better economics, and that's actually not true, because as you move out into the really dense cities, the cost for underground construction skyrockets. Building in New York can be 10 times more expensive than building in Kansas City. So if you look at where Google Fiber has chosen to deploy, it's not in any of the large markets. And that's driven by the cost structures that you see in these markets. So you have, it's almost like a smile, right? The sort of not the tier one markets are far more cost effective to deploy in from a process and just access to infrastructure. And part of that is because U.S. cities don't think of telecom as something that they need to plan for. So they don't lay conduit anytime the street is open. They don't do a bunch of things that make it easy to deploy, either on aerial plant or underground. So in some ways, Waxahachie, Texas has a lot in common with San Francisco from an economic deployment perspective, right? So it's going to be a long time before that happens.
So what Milo just pointed out is that we're facing on the fixed is a civil engineering project, right? It's not about photons, it's not about electrons, it's not Moore's law. It's digging. It's either, you know, stringing miles of something on an aerial plant before you actually have somebody connect, or it's, you know, digging up, streets and trenching, right? So, and this, by the way, is what, for multiple reasons, but this is one of the big reasons why the NBN project in Australia didn't work, right? It was a civil engineering project that they didn't understand was civil engineering.
I would also say one of the problems that NBN had is they said it was going to be universal.
Yeah.
And when you say you're going to build everywhere, you now have the incentive for cities to hold you hostage. Because the cities look at that and say, well, you have to build, so no matter what process I put on you, you'll
Pay up.
You'll have to pay. Whereas if you basically say, which is a new model, if you want fiber, right, you have to make it easy. And I think that more market-based model, where cities that have more advantageous policies will get fiber built faster, will pay off in ultimately changing the rules.
So just one. You asked though about when will you be able to get football into your house, and do you need fiber to do that? And the answer I don't believe is you do
That's
not
correct.
need it. The compression technology has gotten pretty good, so you can get ultra high definition programming now at 15 megabits per second, which is certainly within the realm of even DSL in some cases. So there are ways of doing it, and I agree with you about the infrastructure. I found, by the way, giving coffee to the guys digging the street helps a lot in getting the conduit in. Also paying off the Secret Service. I had to get fiber into my house, and it took a year and a half, but I got it in. But it's right. It was a major issue to get 50th Street dug up.
Those kind of stories you would expect from a third world country.
Yes.
Not from the United
and
States.
by the way, it was the King of Swaziland that actually finally sealed the deal to get my fiber in. But anyway.
Okay, next question.
Hal Vogel, I do my own thing. Two questions very briefly for the panel. One, what do you think is happening with smart TVs? And second, how soon is there the demise of the set-top box?
Greg?
Here it is. This is Google's. These are the little dongles right now. That's the demise of the smart TV and the demise of the set-top box. It's right now. That's all it is. I mean, these little things plug into your TV set. Why switch the TV set out and just put this thing in regular?
Yeah, I think this is one of the challenges. If you just think about how often does the TV in your house turn over versus how often things change in the media playback space, right? It's much easier to have this be separate and pluggable. Is that really a set-top box, though? And I think the question there goes back to, what does it mean to actually have consumer choice? Until the networks are video, linear and VOD are opened so that CE companies like Apple and Sony and others can actually build devices that can handle both linear as well as over the top in an integrated way, being able to differentiate on user interface, navigation, and the rest, we will always be behind. Yeah. And that is too bad, because in Europe and many other countries, we don't have those problems. We are stuck here in the United States.
The comment was made earlier about having a unified search across things. This is the TiVo Bolt. This is their TiVo's attempt to do that. Technically, this can do that. This thing has both coax in, Ethernet in as well. So it'll take the cable TV or over the air, and it will also take in all the on-demand.
However,
channels.
that only works because you have cable card, and cable card is going away.
Yep.
And so once it goes away, the capability for independent companies like TiVo to deliver this goes away, unless there's a successor. And of course, that's what the big fuss at the commission is right now.
Yep.
Okay, next question, and just, we got time for a few more, but quick, and we'll try to get more in.
Quick, Hussein Beyazıt from Istanbul. You were talking about different things about the data analytics and big data, big structure. And there are really new competitive edge or game-changing technologies called semantic web and semantic technologies, including the implication of artificial intelligence, particularly for the search engines. Milo, I think, has some knowledge about it. Do you think that semantic web and semantic technologies, including artificial intelligence, will change the competitive edge of this? For example, Yandex is coming up very interesting as a regional search engine, and also with the content and also multimedia companies. Do you think semantic web and semantic technologies, including artificial intelligence, will be game changer? Thank you.
That's a good question. The TV ecosystem is really driven by IPR and content rights. They constrain so much of the industry in terms of what can be done that I think I think, maybe on the navigation side and searching for content, you'll get that. But I don't think you're going to see that in the actual media delivery. If anything, and I think the panel this afternoon may get into this, I think the move is really that the distribution networks, and despite all what I've said about building the highest quality TV service and building our own devices, et cetera, from Google's perspective, video is transport. We're just moving bits around. And I think ultimately the question is going to be when programmers go direct to consumer, this tension about who controls the set-top box, right? That AMDOC study that I mentioned, cable operators have broadband revenue streams. So if they lose video programming, well, that's not such a big deal. To the video guys, that is a big deal, right? And so because we don't have innovation, because right now the boxes are controlled by the access network, you have this kind of lead weight driving innovation. I mean, there was a study showed, I think, the average life of a set-top box in a cable operator is like 5 years, and it burns more. The average DVR burns more electricity than your refrigerator does, and so that's the kind of dynamic that we have because we don't have a consumer market, and I think that constrains innovation in the video distribution space for linear that we don't see constrained in the over-the-top space, where companies can actually do all this kind of stuff in a much more integrated fashion.
But commenting on that, that's just we're all still assuming that the programming is going to be an entity. The program is going to be something that runs from minute 1 to minute 30 or whatever the length of the time is. But I certainly see a future where if it's all IP and it's all bits, I mean, think about a web page today. That's comes from lots of different sources. I can certainly see a programming where artificial intelligence looks at what I'm interested in and crafts, for example, a news feed, a news program that's based on my interest from multiple sources, and takes the stories at their native story. So I have a 3-minute story from here, a 2-minute story from there. I mean, why do I have to watch just what NBC or ABC or CBS sends out for me?
Because those clips aren't available to you because of the rights issue.
Now they're not. Right now they're not. But once some of the agreements start expiring, and once people start realizing how much cord cutting and over the top, but more even. Again, back to my comment before, I think some of these broadcasters are toast, and I was a broadcaster for many years, so I'm sorry to say that. But there are a lot of very, very good programming now that's coming out of people who are producing this stuff, because it used to be if you wanted to produce programming, you had to be a member of the club. And to be a member of the club, you had to buy hundreds of thousands of dollars of equipment, go into rooms with glass and wear white coats almost, and be in that club, because and the price of admission to the club was paying hundreds of thousands of dollars. This right now is capable of doing 4K, and this is capable of recording and streaming live and broadcasting. So now a lot of people who have the creative capability are going to be able to create this content, and that content is now going to be aggregated, and eventually I think it's going to be put together by the artificial intelligence, as a gentleman just mentioned before, and that semantic is going to actually put those things together. So it's not today, but I do see that as a real possibility in the future.
So, Greg, are you saying it's peak broadcast, and all these guys should sell their spectrum to the commission when they fast?
I would be getting out that
peak
stick,
broadcast.
That
you
stick,
heard it here first.
That stick is going down, guys.
I guess two things. One, I think I tend to usually agree with Milo, and once again, I think that the inertia here, because of the existing rights regimes, and again, it's not just in the U.S., but it's globally, is going to significantly slow that down. Now, the question, though, on the news actually is a little different than the entertainment. The reason is you have other news organizations producing a lot of news content that can be aggregated, and it's video. I can go to, the New York Times that's pushing out its own video. The Wall Street Journal is pushing out its own video. The Financial Times, The Economist are pushing out their own video. So in the news, you do have some old players who are now new players in the video world, and so the rights are a little different. But when you take a look at premium sport, you take a look at sort of first-run movies. Netflix at the margin. You have Beast of Nations. It's simultaneously released on Netflix and in the theaters. That's still at the margin, and I think we're going to just have a the inertia of the lag. Going back, though, to this question, the last question and this question on the
Got to be quick because I got one last question, and we got a time constraint. So, go ahead.
No, I was just going to go to the question of the devices, right? The set-top, I mean, the life of set-top boxes. Again, you have a big embedded base. So as part of our forecast, what I didn't show you is that we're forecasting by 2019 what we're calling digital media adapters, which include things like Chromecast, Apple TV, Roku, et cetera, which are this new, the new version, not the traditional set-top box. That is going to be only about 7% of globally of internet set-top boxes, just because of the inertia of the embedded base. But 7% of the devices is going to represent 32% of global internet set-top box traffic. So there's going to be this disproportionate use, this migration from the traditional box to this new device. And even though the number of those devices are going to be relatively small, it's going to amount for a third of the video traffic, right? That's pretty significant. And that's when you are going to begin to see these changes.
Okay, we have special dispensation to go over 5 minutes, so we get one last question.
I'll try and make it quick. My name is Zachary Smith. I'm from a company called Packet. And my question is for Robert and Milo, a quick follow-on, which is, you mentioned, Robert, in your slide deck around basically an increasing percentage of traffic being delivered via CDNs over time. In the Google Access or Google Fiber Access market, are you seeing that trend today where, A, what percentage of traffic is being delivered within a very, very close peered or CDN kind of local prem style manner? And the follow-on question is, do you see that becomes problematic over time as things like a Comcast, which owns both access and content, maybe creates a competitive environment where they're not encouraged to deliver in that way with you? And do you see that kind of peering or interconnection dynamic changing?
Actually, it's a Milo question. I mean, what are you seeing?
I think there's no question the traffic indicates that moving those caches locally offloads a massive amount of traffic from the long-haul network, which is why it's cheaper for the network provider to do this. We don't do it just for quality purposes. We do it because it reduces the amount of traffic we have to carry over long haul. So there is no good reason from an economic perspective to not co-locate unless you were trying to not make it work as well, because it's just cheaper at higher quality for the users. And I think the challenge is to traditional operators. Some of them have embraced local interconnect. In some ways, it's going back to the future. You remember, it used to be for voice, there was always the issue about interconnecting in local COs. And as the operators merged and developed long-haul networks, no one really interconnects locally anymore. Now, we're not just seeing the edge of the content network move back to local, but I believe, I sit on FCC Technical Advisory Committee, I believe you're going to see compute also move to the edge, because the latency advantage you have by running the compute also at the edge, along with the CDN and the rest, is going to make a material difference in terms of performance. And so having the ability to interconnect locally is going to make a much, much greater difference in the user experience of that operator. And I think the operators that basically say, no, we're not going to let you interconnect locally, you have to talk to us over long haul, I just think that's going to result in a really terrible performance for the user over time. That's not a problem if the user doesn't have any choice.
So just to respond to two things, picking up on what Milo said. First, what we're seeing again in the forecast is that metro and access is growing in terms of the traffic. Essentially, metro is growing 10 times faster than essentially the backbone, and that's because of this. So the real traffic growth is in metro and access, and so there's real evidence of that. Second, I would also completely agree that for latency reasons, a lot of the processing, when people talk about cloud computing, frankly, increasingly, it's going to be, the processing is going to be at the edge, and periodically stuff's going to go back to the data center. You're not going to be going back to the data center for anything that requires low latency. We call it fog computing. Other people call it cloudlets. But a lot of that's going to be at the edge, and that's going to be increasingly important. And then you periodically haul it back.
Only if the operator allows you to interconnect, though. Yeah. So that's the issue.
On that note, I'd like to thank our panel first. Secondly, lunch is here. It's back on the table, and we're starting again 1 o'clock promptly. So enjoy the next hour or 55 minutes. Thank you.
Are your slides available?